Next, we will be moving on to conditional statements, which at their core are statements that change the path for our code depending on certain conditions. For the sake of keeping things simple, for this section, red lines will connote that our code will not be following that specific path, and green lines will mean that our code is following the path. The main type of conditional statement that programmers use is the if statement, and this will show up countless amounts of times in any program you write. It is as simple as it sounds. If some condition is true, and usually the condition will be enclosed by braces, then carry out the instructions located within the if statement's bracket. Else, do another thing. Now, brackets are used in most programming languages to indicate a segment of code which will run. It works like this. If the condition in parentheses is true, then all of the code contained within the brackets will run, and if the condition in the parentheses is not true, then it will skip over all of the statements within the brackets. A quick note is that while this is the case with most programming languages, some like Python use colons and whitespace to determine where a piece of code starts and ends, but for the sake of this series we'll be using curly braces. Now the condition within the parentheses can take on thousands of different forms, such as if the value, the string variable name, is equal to Steven, or if the player score stored in an int variable is greater than 5. The list goes on and on. Each of these statements is evaluated as a Boolean, which you will remember from when we talked about variables is either true or false. If the Boolean is true, we run the code inside the curly braces. If it's not, we pretend everything inside the curly braces never existed and move on with our code. The if statement comes with two more additional statements that can go with it. The if statement comes with two more additional statements that can go with it, else if and else. Else if is a conditional statement used directly after an if statement and carries out mainly the same function as an if statement. However, the else if statement will only be evaluated if the preceding if or else if statement is bypassed due to its condition being false. So we will run through it like so. If something is true, we will run the code inside of that statement's curly braces. Else, if that something is not true, but another statement inside of the parentheses is true, we will then run that code segment. And if neither one of them are true, we will skip both segments of code and move on in our program. This is a hard concept to wrap heads around, so let's do an example. If we had a program that evaluated the if statement, if age equals 10, we could then have a statement under that which is stated else if age equals 12. Now if the age variable was 10, which we can see from the example it is, then the code immediately following that conditional statement in the brackets will run. The else if statement we made will not even be tested, since we know it's going to be false. And this print statement inside of that conditional statements bracket will be ignored, and the code will move on to the rest of the program. Now for example, let's say we change the age variable to be 12 instead of 10. Now instead of the first conditional statement being true, it actually evaluates as false, since age no longer equals 10. So what we do now is first skip over the print statement, which prints out that age is 10, since it's not, and now we evaluate the else if statement, check if age is equal to 12, which again it does. So now we run all the code inside of that conditional statement before finally moving on to the rest of the program. So as a review, we check the initial if statement. If it's good, we run all code within that if statement's curly brackets and move on with our program. If the initial if statement is not true, we then move on to any else if statements and evaluate if those conditional statements are true. We can have as many else-if statements as we want. Although this could lead to clutter among your code, so we will talk about some alternatives later on to help this out. Now that takes care of the if-else statement, so now we will move on to the else statement. The else statement once again comes after an if or an else-if statement and will carry out its instructions no matter what, as long as the preceding statement or statements are evaluated as false. If we went back to our previous program, we could add an else statement which would only have the code in its bracket run if the age variable wasn't 10 or 12. This would catch all cases of the program that didn't fit our parameters. It's good practice to always have an else statement at the end of your conditional statements to catch any weird cases that may come up in your program. Now remember back to the fact that we can have thousands of else-if statements. After a while that can get pretty cluttered, and so another very useful conditional statement which help circumnavigate this problem is the switch statement. A switch statement is functionality similar to many if and else if statements together. You write a switch statement in the form of switch variable in parentheses, then below that you write how many cases that variable could be. For instance, if you wrote switch in parentheses variable, then under it we could write out 5 cases what the variable var could be, and then the instructions listed under that case to be carried out if the var variable is equal to that case. Now switch statements are different, since instead of using brackets they use a colon to signify the start of a set of instructions and a break statement to end it. This is very useful because you are able to essentially use many if and else if statements without having to write nearly as much. In switch statements you just always have to remember to include a default case at the bottom of the expression to denote any and all cases that don't meet the above requirements. This simply catches all of the inputs that don't fit within the program's main cases. It's very similar to an else case at the end of an if-else chain. Now why are these statements so useful? Well, many times programmers want their programs to function differently depending on different conditions. For instance, a program could function differently depending on the information that the user inputs, such as allowing a user to use a program or not use a program if they are above or below 18 years old respectively. Or in, say, a video game, if a user's experience level is above a certain threshold, we want to give them harder opponents to battle. Another example could be a program which changes the color scheme depending on the time of the day. Or even more simply, if a user presses a button that is meant to move on to another screen in an app, the programmer would only want the app to change screens if the user clicks that button. A program without conditional statements will do the same thing every time and will be very primitive compared to one that can change depending on its conditions.